Hello, this is a video to the tool demo, the Quamoco toolchain for quality modeling and assessment. I will show you three parts of our toolchain in detail. First, the Quamoco model editor. Our model editor allows us to build quality models in a flexible way. The key concept is a factor. The factor describes a property of an entity or an attribute of a product artifact. For example, the appropriateness of encapsulation of a class. These factors are organized in a refinement hierarchy, which we see on the left side of the editor. Details to these factors can be found on the right side. We can explore the model using different views, such as the factor hierarchy, the entity hierarchy, or the measure list. Measures are there to operationalize the factors. For example, the appropriateness of encapsulation of a class is measured by should be static. Tools can collect data for these measures directly. This is specified in the instrument. For C#, should be static is measured by gendarme. We also support manual instruments for aspects that cannot be measured automatically. For the evaluation of quality, we can define impacts from one factor to another. For example, we specify impacts from the properties of product parts, such as the appropriateness of encapsulation of a class, to higher level quality attributes, such as analyzability or the effectiveness of an attack. Along the refinements and impacts, we specify evaluations. For that, we have built the Quamoco impact evaluation language Kiesel, which is based on Java. It provides a set of functions to normalize measurement results for the whole system and evaluate them in terms of quality points. These points are then aggregated to the higher level attributes by the impacts. Second, the generation of a concat block. To conduct an evaluation, we need to integrate a quality evaluation tool, in our case, concat. Concat uses so-called blocks to describe the evaluation it has to perform. As all evaluation information is specified in the model, we can generate such a block for a technology. For example, I can right-click on the C# module and select Generate Concat Block. I then have to add where the block should be saved, what it should be called, and what implementation language we're evaluating. In this case, C#. Then the block is generated. Third, the concat runtime. In a graphical editor, I see the generated block. It includes all tools we need for the analysis. In fact, however, I don't need to understand or change anything in here. I only build a wrapper block to provide the generated block with necessary information, such as where the C# code and assemblies are located on my hard disk. We can also configure how the result is displayed. Here we choose a table HTML representation. The run configuration contains values for the needed parameters, input, output, mapping, and include patterns. And we start the concat run. After concat has finished, we can open the results in a browser. The main output resembles our refinement and impact hierarchy of factors. Here we can find our factor appropriateness of encapsulation of a class. With 99 points, which result from 4 findings of the should be static measure. This concludes our demo.